Good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Grade 10, today we're going to look at the tangent graph. Do you know the tangent graph? Yes, you're going to learn about the tangent graph, and we're going to look at the effect of A and Q. We're going to look at the effect of A and Q. You can even write there your topic, the tangent function, effect of A and Q. Let's be ready for our lesson, grade 10s. Remember our WhatsApp line 079 454 9535. We ask our questions as we proceed with the lesson, okay? So that I can be able to answer some of your questions, okay? Right. Let's make sure that we are ready for our lesson. Right. At the end of the lesson, you should be able to study the effect of A and Q on the graphs defined by f of x is equals to A times tan x plus Q. Okay. And then we are going to sketch and interpret graphs based on the observations of A and Q. We'll try to move slowly so that we move together and we understand what we are going to learn today, okay? Right. If I'm moving fast, please make sure you send us a message. Okay, you can send us even your work, grade 10s. Send us your work also. Even your questions are very, very important. Okay, please do ask questions. Don't be afraid. Feel free. Right, we've done the tangent graph, the basic tangent graph, the functions and the asymptotes. We're going to talk about these ones today. Right, now this is what I want us to do now. I want us to do question 1 and question 2 for 3 minutes, and then after that I'll tell you when to do question 3. Right, question 1 says the graph of f of x is equal to tan theta for our domain from 0 to 360 degrees is asymptotes where a theta is equal to what and a theta is equal to what. So there are two asymptotes within this domain. Remember, the domain is going to be bigger as we move to the higher grades, but grade 10s we're looking at what from 0 to 360 degrees. How many asymptotes do we have? We have 2 of them. Where are they? We answer that, and then question 2, you find the values of tan 45, tan 135, tan 225, tan 315 degrees. And I'm going to tell you why we chose these points or these tan 45 or these angles 45, 135, 225 and 315. Okay, let's do question 1 and 2 for 3 minutes. Welcome back, grade 10s. I hope you managed to get the correct answers. Please remember that this is not a test as such. We are in a lesson, isn't it? So feel free even to discuss in your classrooms there. Okay, feel free, but there must be order. Don't make noise. If I give you something to do, you are free to discuss if you can. But if it's bringing disorder, then let's make it individual work. Okay, right. Now, let's look at the answers now. The graph of tan theta for our domain from 0 to 360 degrees is asymptotes at theta when the angle is 90 degrees and when theta is equals to 270 degrees. Remember, theta, it can be x, it can be any other variable there. Right, so the angle at 90 degrees, there is an asymptote. In 270 degrees, there is an asymptote. It is very, very important for you to know this. Please write it down. We are going to be using this as we are sketching our graphs. Where are the asymptotes? At 90 degrees and 270 degrees. Okay, so here we're looking at the effect of A and Q. So these asymptotes are not going to change for now. Okay, they are going to talk about the changes in the asymptotes later, but for today's lesson, our asymptotes are at 90 degrees and 270 degrees. Okay, all right, tan 45 is 1. Remember that these are critical points that will assist us in sketching the graph, the tangent function. These are critical points that will assist us to sketch what? The tangent function. At 45 degrees, we know the graph of tangent function is at 1. Right, tan 135 is -1. You can write these ones down, please. Okay, if you're marking, mark. If you're making corrections, make corrections. Tan 135 is -1. Because after this, I will ask you to sketch the graphs using this, what we are discussing now. So make sure that you have this in your notes. And then tan 225 is 1. Tan 225 is 1. 225 degrees, sorry, is 1. And then tan 315 degrees is -1. Please write it down. Write it down. Right, before we move on, let me give you 1 minute to make sure that you write these key points, the asymptotes and our critical points. Let's write these notes down. 1 minute. Welcome back, grade 10s. I hope you have managed to write your notes. We're going to use these as we sketch the graph of tan theta and the other graphs. Right, now I want us to discuss this before we move any further. The critical points for the graph, for the tangent function. Right, every 45 degrees, you must know what is happening, isn't it? Let's discuss. At 0 here, what do we have for the graph? It is, we have the x-intercept. We have the x-intercept. And then at 45, what did you say tan 45 is? Tan 45 is 1. Okay? Every 45 degrees, there's something we must know about. Right, now at 90 degrees, what do we have at 90 degrees? We said what we have? We have our asymptote. We have our asymptote at 90 degrees. And then at tan 135 degrees, what is it? It's -1. You must know that. And then 180, what is it? 180 degrees, we have the x-intercept. Okay, just listen here. You don't need to write anything down. We're going to talk about this when you sketch the graph. Right, now 180 degrees is the x-intercept. And then what about tan 225? You have that tan 225 is 1. Okay. What about 270? 270. If you say tan 270, you get undefined or error. That's where the asymptote is. You see, we say the asymptotes are at 90 degrees and 270 degrees. What about 315? What do you get for 315? It was -1. And then 360 is the x-intercept. So the x-intercept is 0, 180, and 360. Okay, and then the other critical points, I said you must write them down. We're going to use them. Then you can easily sketch your graph. I'm going to show you how you sketch the graph, and then you're going to repeat this. Okay, we're going to sketch the graph after, but let me show you. Then you can just join the points. The graph is approaching the asymptote, but will never touch it. The graph is approaching the asymptote, but will never touch it, like this. You see that? That's our tangent graph. You see that? That is our graph. Okay, right. Now let's move further now. Proceed. Let's proceed. Right. On the given template, sketch the graph of f of x is equals to tan theta. Do you remember what we discussed? In these critical points, I want you now to sketch the graph of tan theta. Let's try to do that. I'm going to give you 3 minutes. Welcome back, grade 10s. I hope you managed to sketch your graph for tan theta. Did it come out nicely? Okay, let's try to do it together now, and then you can copy that once I'm done. Right, so now we have our asymptote there at theta is equal to 90 degrees, and then we have our asymptote there where theta is equal to 270 degrees. Do you see that? Okay, and then let's put our x-intercepts. Where do we find them? At 0, at 180, and at 360. Right, let's go to our critical points that we talked about. At 45, tan 45 degrees, what is it? It's 1. So we put 1 there. And then tan 135 degrees, what is it? It's -1. So we put -1 there. And then tan 225, what is it? It's 1. We put it a dot there. We are plotting. And then at tan 315 degrees, what is it? It's -1. Do you see that? And then we sketch our graph. This is the graph for tan theta. F of x is equals to tan theta. Don't erase this graph. We're going to draw other graphs on this Cartesian plane. And then I'm going to give you 1 minute to just copy to correct your graph if you got it wrong. And then we're going to use it later. Please make sure that your diagram is big enough, and make sure it's neat, because we're going to draw other graphs on top of this one. Okay, right, let's have 1 minute to correct our graphs. Welcome back, cretins. Did you manage to sketch it? Did you manage to correct? Okay, right, now let's see what we have to do. Okay, this one we have discussed this, but let me just repeat it. Okay, we say these are the critical points which are very, very important when we are sketching our graphs. Okay, these are the critical points. These points are useful when sketching tangent graphs involving the vertical stretches. Like we're talking about the effect of A. Remember, the effect of A causes what? It's going to cause the vertical stretch. So these critical points are going to assist us a lot when you're sketching the graphs. When the A changes, maybe if A is 2 or A is 3, what will happen to the critical points, right? And then reflections about the x-axis and the y-axis. Like on this lesson, we're going to talk about later, we're going to talk about reflection on the x-axis, right? And then we have vertical shifts also, the effect of Q. We have seen that in the other graphs, that Q, what? Causes vertical shift, upwards or downwards. You see that? So these critical points are very, very important when it comes to these transformations, right? And then we'll sketch the graph of f of x equal to tan theta. Remember, I said draw that graph and leave it there. So we're going to draw the graph of g of x on the same set of axes, and then we're going to draw the graph of h of x on the same set of axes, and then we discuss and talk about the key features after that. Okay, right, so now let's go there. I'm going to give you the table, and then you sketch the graph of what? Of g of x. Let's do that. Now the first point, you are taking your theta is 0 and your y is 1. So your first point, the coordinates here will be 0 degrees 1. And then the second coordinates will be 45 degrees and what? And 2. You see that? Okay, I've just given you 2 examples. You can do the rest. Let me give you 3 minutes to sketch the graph of g of x. Use the table. I've already done the table for you for 3 minutes. Right, welcome back, returns. Let's sketch the graph of g of x, and then I'm going to sketch arm by arm. But it does not mean that these are three different graphs. This is one graph. You know that, okay? But it's just a discontinuous graph because of the asymptotes, okay? But it's one graph. Remember, just like what the hyperbola, do you remember that? It is one graph, the other arm this side, the other arm this side. It's the same thing here. So let's start with the first arm here. So 0 and 1, the point is there. Do you see that? Did you plot it correctly? And then 45 degrees and 2 is there. And then what has happened to the parent graph here, the red graph, is like shifted upwards by how many units? By 1 unit. Our Q is positive 1. So it's going to go up by 1 unit. Do you see that? The graph has been shifted upwards by 1 unit. Let's check the other points. The 135 degrees, it's 0. You see that? 135 degrees, it's 0. And then 80 degrees, 180 degrees at 1. 180 degrees at 1. And then 225 degrees at 2. That is the point there. You see that? It's like the arm is shifted upwards by how many units? By 1 unit. Okay, by 1 unit. Right. And then we have the asymptote there. After the asymptote, 315 degrees, 0. You see that? That is the point there, the blue point. And then 360 degrees is at 1. That is the point. So you see the graph is shifted upwards by 1 unit. What is the effect of Q? It is vertical shift. If it is positive, the graph goes up by Q units. Okay? Right. Now, if you got it wrong, wait. I'm going to sketch the graph of h of x, and then I'll give you time to copy these two other graphs. Okay, remember we already have our f of x. Okay, right. Now, let's go to our h of x. This is our h of x now. What is going to happen here? Our q is negative 1. Our q is negative 1. So the first point here is 0, negative 1. That is the point. The second point is 45, 0. That is the point. Do you see that? So the graph, the parent graph, which is our red graph, was shifted downwards by 1 unit because the q is negative. Okay? Right. We have our asymptote at 90, 135, negative 2. You see that? And then 180 degrees, negative 1. Do you see that? Okay. Do you see the points? And then 225 is 0. Do you see that point there? Okay. And then what has happened to our parent graph? It was shifted downwards by 1 unit. That's the effect of Q. Right. We have our asymptote there. And then 315 degrees is negative 2. There it is. And then 360 degrees is negative 1. There it is. You see that? The graph is shifted by 1 unit. Okay, downwards by 1 unit. Do you see that? Okay, now let's sketch our 3 graphs. We already have our red graph and maybe the blue graph if you got it right. Now I'm going to give you 1 minute to sketch your graphs. You must have a diagram like this with all the graphs. The g of x, the h of x, and f of x, on one axis. Let's do it for 1 minute. Well done, Cretans. Well done. Well done. Let's continue with our work. Right. Now, what do we say about this? Let's look at the critical values, okay? I'll just discuss the critical value at 45 degrees and then I'll give you the rest, okay? And time to just copy, okay? Right. Now, let's see for tan x, 45, it had 45 and then and 1, which is this, isn't it? This is the point we're talking about, 45 and 1. Now, when Q is 1, positive 1, what happened to the y coordinate of our critical value? It increased by 1. Do you see now it is 40? It's going to be 45 and 2. Do you see that? So we've added 1 to the y coordinate of the critical point. You see that? So now it's 45, 2. Does the x coordinate change? No, it does not change. Right. And then now negative 1. What do we do to this point here? The 45 and 1. This is our point for our parent graph, the red one. So if Q is negative 1, we say 1 plus negative 1, which is 1 minus 1, which is 0. So that's why this point is 45, 0 there. Do you see that? The x coordinate of the critical point does not change. It is only the y coordinate. If Q is going to be 3, it means you're going to add 3 to the y coordinate of the critical point. So it's going to be the same for all the critical points. Even for this point, we're going to add 1 to negative 1, we're getting 0. And then for our h of x, we're going to say negative 1 plus negative 1, which is negative 1 minus 1, which is negative 2. Do you see that? Okay, right. Now you can copy the critical points for the different graphs. Remember, you have to write the equations so that it will make sense. Otherwise, you write the critical values on their own, then it does not make sense, isn't it? So now copy. You don't need to draw the table. Just write the equation and then its critical values, and then the equation and its critical values. And then after this, I will show you the other two critical values. Then we move on after that. Just 1 minute. Well done, grade 10s. Let me give you the other critical points, and then I'll give you a minute to copy those critical points. Remember, WhatsApp line, grade 9s, 079 454 9535. Okay, right. These are the other critical values. Can just continue from the previous ones, and you write these critical values. Okay, for 1 minute. Let's do it. Well done, grade 10s. Let's move on. Right, now we have our graphs here. We saw that f of x shifts upwards by 1 unit to form g of x, okay? And f of x shifts downwards by 1 unit to form h of x. If our q is negative 3, it means the graph was going to shift by 3 units downwards. If our q was positive 4, the graph was going to shift by 4 units going upwards, okay? Right, do we have the range? What can you say about the range? The range, remember, range is the y values. Okay, where does the graph start? Where does it end? Okay, what's the range? You can try to raise your hand there in the classroom and give us the answer. What is the range for the graph of tan theta and these other graphs? Tan theta plus 1, tan theta minus 1. What is the range? Y is an element of negative infinity to infinity. You can see this graph goes on. Even the arrows, they point down there. And then also there. So this side is negative infinity. This side is positive infinity. So it's from negative infinity to infinity. So y is element of negative infinity to infinity. Or you can just say y element of real numbers. Done. Okay. So that's the range there. Okay. This is range of this. Can you write it down for 30 seconds? I'm not going to go anywhere. I'll wait for you. Just write range, y element of real numbers, or y from negative infinity to infinity. Let's do that for 30 seconds. Good. Well done. Now, what about the maximum or minimum values? Do you see any there? Do we have any maximum or minimum values? We don't have. Do you see that? So the graph of tan theta plus q, we don't have what? The minimum or maximum values. We don't have that. Okay, just know that. You don't need to write it down. It's fine. And then the period for these graphs, the three graphs. What is the period for these three graphs? And let me give you 1 minute. Please discuss this and try to come up with your answers. After 1 minute, then I'll show you what it is. Did you get the period, grade 10s? Is it 360 degrees? No. 360 degrees is for what? For the graph, the cosine function and the sine function. Okay, do you remember that? 360 degrees is the period for the sine function and cosine function. What is the period for the tangent function? It is 180 degrees. The graph repeats itself after 180 degrees. Okay, right. Do you see that? Okay, so from 90 here to 270, remember, is 180 degrees. Remember, this graph is going to continue like this, goes on. It's on that our domain here is what? From 0 to 360 degrees. Even here, it goes on like that to the left-hand side. Okay, but here, what you say, the graph will repeat itself after every 180 degrees. So that's the period for the tangent graph. Okay, right. Now, I want us to look at the effect of A now. We have looked at the effect of Q. We are fine. Now let's look at the effect of A. Sketch the graph of f of x is equals to 2 times tan theta. What is A in this case? It is 2. And then g of x here, which is, what is A here? Is negative 2. We'll see the effect of 2 when it changes, it becomes negative 2. And then here the effect of Q, we have talked about that. That is vertical shift. Right, on the same set of axes for the domain 0 degrees to 360 degrees. We are going to do this. I've already done the table for you, so you're going to sketch the graphs. Okay, right, let's do it like this. I'll give you 2 minutes to draw your Cartesian plane. Make it big, learners, make it big so that you can draw your neat graphs. Okay, don't make it small, otherwise you won't see what you're doing. Right, and then 2 minutes, let's draw our Cartesian plane, and then after 2 minutes I'll tell you what to do. Let's do it. Welcome back, grade 10s. We got a very good question from Palm Ridge Secondary School. Thank you very much for that question. It says, do the critical values change when the period changes? Okay, right. Let me just explain this and then we go back to the objectives for today's lesson. Okay, right. So we said we're looking at the graph of the form f of x is equals to a tan x plus q. Okay, so we're looking at the parameters a and q. Okay, so in this case, our period is not changed. Later on, we're going to look at the graphs of the form a tan kx plus q. So I don't want to create confusion here, but let me just tell you what it does. Now, this k here is the one that changes the period of the graph. And then when the period of the graph changes, yes, the critical points, the coordinates of the critical points will what? Will change. But now we are not doing this now. Okay, we'll do this one later. So let's just concentrate on the parameter A and Q for now. But thank you very much for that question. It's a very, very good question. I really understand that this question should be coming from someone who understands trig functions. Thank you very much. Right. Now, what are we doing? We're sketching our graph. We're sketching our graphs. And then let's start with f of x. Let's go straight 0, 0. There it is. Oh, I started with the asymptotes at 90 and 270 degrees. And then this is 0, 0, the point there. Do you see it? And then 45, 2. Oh, what has happened? It's now 45, 2. Okay, our tan theta graph, it was 45, what? 1. You see? Something has changed there. Right? And then 90, what? Asymptote, 135, negative 2. Oh, it has changed. You see that? It was 135, negative 1. Now it's 135, negative 2. You see that? And then 180, 0. 180, 0 is there. And then 225, 2 again. You see? Right. And then 270, that's the asymptote. 350, negative 2. Do you see that? Okay. And then we can sketch our graph like that. We can sketch our graph for 2 tan theta. Do you see that? Okay, for us to understand the effect of A, let me just do this. I want to sketch the graph of tan theta. I will try to sketch a graph of tan theta then. Let me just pick another column. It to be here, here, there, and there. And then it's going to be like this. Okay, it's going to be like this. It's going to be like this. Then it's going to be like this. You see that? You see, this is the graph of tan theta. So what has happened here? What is the effect of A? What is the effect of A? Was the graph shifted upwards? It didn't shift because this point did not shift, this point did not shift, this point did not shift. You see that? So we can't say the graph was shifted upwards or downwards. No. What changed here? The critical values from 45 degrees 1 to 45 degrees 2. See that? So here it's like the graph is vertically stretched. It's like someone pulled it like this from the top and from the bottom, then you stretch it like this. It's like vertically stretched. So A vertically stretches the graph. If it increases, the graph becomes vertically stretched. That's the effect of A. You see that? Okay, so now we have seen the effect of A. I'll try to squeeze everything into one thing so that because of time. Now we want to see if A now is negative, what will happen? Remember this. Let me clear the ink here so that we can discuss before we go to the next one. Right, remember we said the transformation of f of x to negative f of x. What is it? Like from 2 tan theta to negative 2 tan theta. What reflection is this? Is it about the x-axis? Is it about the y-axis? Who remembers? It is a reflection about the x-axis. Okay, let me reflect this arm. You see? Let me reflect. I have reflected this one. Let me show you. Maybe it's too faint here. Let me show you. You see this arm here? It's a reflection of that arm there about the x-axis. It's the mirror image. It's like this one is our mirror. This one is our mirror. It's a reflection. You see that? And then let me reflect this one. You see? This one is reflected like this. You see? This one is reflected. And then this side is reflected this side. So it's a reflection about the x-axis. Okay? What about this arm? This one. How is it going to be reflected? It's going to go to the top, isn't it? That's a reflection about the x-axis. That's a reflection. Right. So from tan to tan theta to negative 2 tan theta, that's a reflection about the x-axis. What about this plus 1? What effect will it cause? Then this reflection is going to happen. What is going to happen to this reflection? First of all, it's going to be reflected about the x-axis. Then after that, what happens? And then after being reflected, it is shifted upwards by 1 unit. I want us to sketch this graph using the points, using the table. I want us to see if it's going to be reflected and then shifted upwards by 1 unit. Okay? We're expecting that now. So want to reflect, we'll reflect and shift by 1 unit. So we're going to use our points and see if that is going to happen. We're going to use these points. This point, this point, this point, this point like this. And then see if that is going to happen. A reflection about the x-axis and then shifting upwards. Let's see. Right, I'm going to give you 2 minutes to sketch the graph of g of x. Please use the points. 0 goes with 1, 45 goes with negative 1, 135 goes with 3, 180 goes with 1, then 225 goes with negative 1, 315 goes with 3, 360 goes with 1. Let's use the points, plot the graph, plot the points, and then sketch the graph. Want to see if it is going to be a reflection about the x-axis and the shifting upwards by 1 unit. Let's do that for 2 minutes. Welcome back, grade 10s. Thank you very much for the input. I understand some people now, they can't understand because I'm moving fast. Thank you very much. Let me try to slow down. I was busy checking my time and then thinking that, oh, let me rush. Okay, but it's fine. We want to understand what we are learning. That's the most important thing, okay? Right. But if there's something you do not understand, remember, you can even rewind the video a bit, go back and check where you missed something, okay? Maybe even after is okay. Right, but now let's try to move a bit slowly, sorry. Right, let's plot our points. Let's plot our points. We said 0 goes with 1. Where's 0 and 1? There. Oh, I started with the asymptotes. I always forget this. Okay, the asymptotes. Then 0 goes with 1. Do you see the point? The blue ones. Just check the blue dots. 0 goes with 1. 45 degrees, negative 1. Do you see that? Okay. You can plot as I show you. If it's wrong, you can correct as I show you. And then 135 goes with 3. We're using the table. 135 degrees goes with 3. Oh, I drew the arm there. 135 goes with 3. There it is at the top there. 135 with 3 there. And then 180 goes with 1. 180 goes with 1. Okay, see that? And then 225 goes with negative 1. Right, and then 315 degrees goes with 3. Oh, before that, we sketch the arm there. I'll give you time to copy, don't worry. Then 315 goes with 3. There it is. Then 360 degrees goes with 1. There it is. We have our graph for h of x there. Let's name it h. Oh, sorry, g. Let's name it g. The graph for g. Okay, let me give you 1 minute. And then after that 1 minute, we are going to discuss. 1 minute, I want you to draw your graph correctly now. Make sure that they are neat. And then after that, we are going to discuss our graphs. Let's do it for 1 minute. Right, welcome back, grade 10s. Do you understand now? Okay, please. I hope that you managed to understand what we've discussed. Right, we say that the graph of g of x, because you see yes 2 tan theta, here we've got negative 2 tan theta, then that will be a reflection about the x-axis. You see this reflection of the red graph? Reflection about the x-axis. And then after that reflection, we have seen that the points have moved upwards by how many units? By 1 unit. It is because of this plus 1 here, positive 1. Okay, right. And then again, oh sorry, right, again here we see that this is reflection when 2 tan theta becomes negative 2 tan theta, then the points are shifted upwards by 1 unit. You see that? Okay, so reflection here about the x-axis, then the points are shifted by 1 unit. You see that? So it's like this is f of x becoming negative f of x plus 1. You see that negative f of x is a reflection about the x-axis, then plus 1, the shifting upwards by 1 unit. Okay, right. Now, let's discuss this together. Right, explain the transformation of f of x to form g of x. Remember, our f of x is the red graph. For the graph defined by f of x is equals to a tan theta plus q, what is the effect of q? What is the effect of a? We have talked about this. Let me just sort of like, it's like summarizing now. So we say that the graph of f is reflected about the x-axis and then shifted upwards by 1 unit to form the graph of g. Okay, the graph of f is reflected about the x-axis and then shifted upwards by 1 unit to form the graph of g. Okay, right. And then what is the effect of q? We have seen that q causes vertical shift. If q is positive, the graph will go up by q units. If q is negative, the graph will go down by q units. What is the effect of A? What did you say? What's the effect of A? What did I say? Who remembers? We said A causes vertical stretch. Vertical stretch. So A stretches the graph vertically. Okay. Don't forget that learners, we have managed to what? To learn about the effect of A and Q. Okay, and I really hope that everyone is participating there in the classroom. You're doing your work, you're asking questions, you're discussing in ordered manner without disturbing others, and we are enjoying the lesson. Okay, right, this is your homework. I'm going to give you 2 minutes to copy the homework. Then after that, you can do it and submit to mem or say. And then let's do that for 2 minutes. Welcome back, greetings. We are done now. Let's just summarize our lesson. We got some comments about the speed, a bit late, but I really hope that you can rewind the lesson a bit and try to check where you have missed something. Okay, next time when I start to accelerate, sometimes I do accelerate, just tell me, say, please slow down very fast so that you don't miss things. Okay, right. But I really hope that you can rewind a bit and catch up. I know the last part about the effect of A there. Things were a bit compressed into one thing, and then it may be difficult for us to understand. But okay, right, please do try to continue even checking your work, your notes, your textbooks, and passes and papers, and continue practicing, you're going to be fine. Okay, right. And then now let's go to the summary. What did we say? For the graph of f of x equals to a tan theta plus q, the graph has no maximum value, no minimum value. And then the range, we say y is element of real numbers, or y from negative infinity to infinity. And then for the graph, for the domain 0 to 360 degrees, the asymptotes are at 90 degrees and 270 degrees. Okay, we also talked about the points where we have our x-intercepts. I really hope that you will understand this, or you are not going to forget this. Okay, right. Thank you very much, grade 10s. We are going to meet in our next lesson. Enjoy the rest of your day.